Alright, today we're going to take a look at writing quadratic functions. This is lesson 4.10 in your book. So a couple things we need to recall is vertex form, which is written here for us. This is our y equals a times the quantity x minus h squared plus k. Remember that hk is the vertex, and we are going to take the opposite of that h value to find the vertex of your x, and that's going to be your x value, and the k is the y value. Then we have our standard form, y equals ax squared plus bx plus c. So the first example we have, we're going to write the quadratic function in vertex form with the information that they gave us. So from the information that they gave us, we have a vertex of 4, negative 5, and it passes through the point 2, negative 1. So if I look at my equation for vertex form, I have minus k, or plus k, sorry. I have values for everything to plug in except for my a value. So the point that it passes through, we're going to take that negative 1, plug it in for y. Then my a value is going to stay. Your 2 is going to go in for the x. And then we're going to take the values for our vertex and plug those in. So minus 4 squared plus, oops, sorry, this should be minus. Minus 5. From here we can go ahead and solve. 2 minus 4 is negative 2 squared is going to give me 4. So I have 4a minus 5 equals negative 1. Add 5 to both sides. And I have 4 equals 4a. So my a value is going to equal 1. So now I can rewrite my equation in vertex form. So I have y equals, my a value is 1, so I'm just going to have x minus 4 squared minus 5. So that's all we have to do for that example. Use the information that they give you and plug it back in for x and y and h and k. Now, if we take a look at our second example, it's a little bit different. Still, we're going to write the vertex, or write our equation in vertex form. So we are going to do this by completing the square, which is what we did in 4.7. So if we take a look, we have, and is review, we did this before, but if we take a look here, remember when you have your equation that we are going to write in vertex form, if we take half of that b value and square it, that'll give us our value here. Then we're going to leave our plus 5. Then we're going to subtract off whatever it is we added on here. So half of b squared is going to be 4. And then on the other side, I'm going to subtract 4. Now from here, this is a perfect square trinomial. So this can be written as x minus 2 squared. And then 5 minus 4 is 1. So again, my equation is written in vertex form, and my vertex here will be 2, 1. So again, this should be review for you. We did this in 4.7, but if it looks new to you, then there's the example again. So we are just running through how to write in different forms. Now, if we take a look at example 3, this one looks a little bit different. The difference here is it gives us 3 points to work with. We are going to write our equation in standard form. So standard form is going to be that ax squared plus bx plus c equals 0. If you look, each of these give us an x and a y. So what we're going to do is plug these points in for each. So if I take a look at my first point, I have negative 1 equals, so that's my y value. Then I'm going to plug in for x. So a times negative 1 squared plus b times negative 1 plus c. Then I have my next equation. 11 equals a times 1 squared plus b times 1 plus c. And then the last one here, I have 7 equals a times 3 squared plus b times 3 plus c. Now, I can simplify and rewrite this, so I have a minus b plus c equals -1, and that's when I simplify that top equation. The next one I'm going to have a plus b plus c equals 11. And then the last one, I'm going to have 9a plus 3b plus c equals 7. Now from here, remember we solved systems with 3 variables. We're going to do the same thing that we did before by placing this into a matrix to find our values. So if I take the coefficients in front here, so on the top one I have 1, -1, and 1. The next one here I have 1, 1, and 1. And then that third equation I have 9, 3, and 1. Again, I'm just taking the coefficients from in front. So these are all 1s that I'm placing in. Then remember, in your calculator you're going to take the inverse of that times the constants on the other side. So 1, 11, and 7. When you solve here, you get 2, 6, and 7. These are now your values for A, B, and C. So now to write this in standard form, I'm going to have y equals 2x squared plus 6x plus 7. So this is my answer written in standard form. Now remember, you can either plug these in your matrix either by going to that alpha y equals screen or by going to the math and then over to matrix and editing your list that way. Either way will work here. So if you guys can go to the next page, what I want you guys to do is pause the video now and go ahead and try these 2 problems on your own, and then you're going to check your answer. So again, I'm going to plug in the information that they give me. 4 equals a times 0 minus 1 squared minus 3. So if I simplify here, I have -4 equals a minus 3. Add 3 to both sides. So -1 equals a. So when I rewrite here, I have y equals -1 times x minus 1 squared minus 3. When I move to the second example here, again, you're going to plug everything in for x and y. So I have 7 times -2 squared plus b times -2 plus c. Next one I have 3 equals a times -1 squared plus b times -1 plus c. And then the last one, 7 equals a times 3 squared plus b times 3 plus c. From here then, inside your matrix, we are going to have 4, -2, 1, 1, -1, 1, 9, 3, and 1. Remember, you're going to take the inverse of that, and you're going to multiply it by the constants on the other side, so 7, 3, 7. From there then we get 1, -1, and 1. Again, those are your answers for your A, B, and C. So now to write your equation in standard form, I have y equals x squared minus x plus 1. So this is my answer here. Alright, so again, we'll go through this stuff in class tomorrow to review, but make sure you are listening to the video. If you have questions, make sure you come prepared to class to ask them.